Now that we have some conceptual understanding of unsupervised learning and the different goals of unsupervised learning, let's dig right in with one popular approach to unsupervised learning. K-means is a clustering algorithm, an algorithm used to find homogeneous subgroups within a population. K-means is the first of two clustering algorithms to be covered in this course. The K-means algorithm works by first assuming the number of subgroups or clusters in the data and then assigns each observation to one of those subgroups. In the next video, we'll go deeper into how the K-means algorithm works to achieve this goal. For example, one might hypothesize that this data shown on the screen contains two subgroups. The K-means algorithm would assign all points in the top right-hand corner to one subgroup and all observations in the bottom left-hand corner to the other subgroup. K-means and R comes with the base R install. Invoking K-means and R is simply a function call to the K-means function, typically with three parameters. The first parameter is the data, represented as X here. In K-means, like many machine learning algorithms, the data is structured in a matrix with one observation per row of the matrix and one feature in each column of the matrix. The next parameter for K-means is the number of predetermined groups or clusters. This parameter is called centers for reasons they'll be covered in the next video. Finally, the K-means algorithm has a random component. The implication of this stochastic component is that a single run of K-means may not find the optimal solution to K-means. To overcome the random component of the algorithm, K-means can be run multiple times with the best outcome across all runs being selected as a single outcome. nStart is the parameter that specifies the number of times K-means will be repeated. There are other parameters to K-means, and I encourage you to check those out in the R documentation when you're ready. The first exercises use synthetic data that were generated from three subgroups, but if you plot the data, it might only appear to be two subgroups. Later in this chapter, you will see how K-means can be used to estimate the number of subgroups when the number of subgroups is not known a priori. Later in this first chapter of the course, you'll get experience applying K-means with a real-world but fun data set. With that information, let's get started on the first exercise using K-means.